I will begin with a word of prayer here. Forgot to bring my whistle. Hopefully you guys can hear me. Ahem. 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 Dear Father, we thank you for today. I thank you again for these students. Just ask you to be with us today. Help us to glorify you in what we do, and just to understand the math that we're going over, Lord. In your name I pray. Amen. There is a quiz when? Thursday. That is true. Are you guys ready? Yeah? Can you use a calculator on the quiz? Yes. You can use a calculator. Pretty much any calculator is fine, although not a calculator on your phone. Phones are not allowed. Other questions? So I need the talking to stop while I'm talking in here, because otherwise I can't hear myself think, and I can't hear questions when people are talking. So once I start talking, you guys got to stop talking. Okay? So the question was the note card. What was your question?
So does the note card, can it be like a sheet of paper, or does it have to be like...
Oh, yes. The note card can be, you don't have to have a note card. You can have a sheet of paper like these, front and back, whatever you want on it. Formulas, quotes, picture of your beloved, whatever. It's all good. Truth tables, maybe. I don't know. Other questions? Yep.
Do we have really bad handwriting? Can we print out?
Oh yes, you can certainly type out. You can print it. That doesn't have to be handwritten. Sure. Yep. The quiz goes through 3.4. So the quiz, I intend for the quiz to basically be a pretest. So like you have quiz 1 and test 1. So quiz 1 should somewhat resemble test 1. I just want to give you like a preview of what my test likely looks like. So I'm not saying it's exactly the same, but there should be some strong overlap between the quiz and the test, at least stylistically, if not the questions. Probably the questions won't be exactly the same, but format-wise, I'll try to be somewhat close. Yep. It is, that's up to you. I allow you a page of notes for the quiz, and I allow you a page of notes for the test. I do not collect this page of notes. You keep it. So I will give you a paper test, a paper quiz. I will physically bring you a piece of paper. I will hand it out. You will write on it. I will collect it. I will grade it. And then you'll get it back. Now the test is on Tuesday, right? So if you want to get it back before the test, you'll have to come see me. Yep. How long is the quiz and the test? I think it's the class period. Oh, enough? Other questions? I don't know. I haven't made it yet. But is that a large notebook? Is that a regular size notebook? What kind of notebook are we looking at? It's not like some kind of artist tablet. You're not trying to pull one on me, are you? That looks to be an ordinary size piece of paper. Yeah, lined is fine. You don't, whatever. Once upon a time there were theoretical physicists who were doing calculations that were so long that they made the habit of carrying around artist tablets to do their calculation, So the pages are more like this by like that, but no, regular size piece of paper, only 2 sides. No 3-sided or 4-sided paper, please. Just saying. These are good questions. Yes?
On the Cengage for the homework, is there anywhere else on there that we can do like a pre-quiz or pre-test?
No.
Right.
There's no pre-quiz or pre-test on Cengage. That is not the case. That's why I'm giving you a quiz in class.
Okay.
Yep.
What do you suggest is other than just going through every homework module, is there a better way to prepare for your quizzes and exams?
I don't think so. I think just pretty much look at the homework, look at lectures, think about what we've talked about. It should be good. I'd say look at past exams and past quizzes, but it's the first time I'm teaching it. So. I will say this though, don't stress too much about the quiz. I mean, the quiz is worth some points, but I always try to include a little bit of like bonus in the quiz. So if you've got an 80% understanding, you should be able to get 90% of the credit, something like that with the quiz. There's probably going to not be quite as much wiggle room on the test, but on the quiz I include some bonus because, we're still learning. Yep.
Is the test going to be up to 3.4?
Yes, yes. So the test and the quiz are both through 3.4. Yep. Yep.
So did you say that you're going to be also scoring us on class participation during the quiz? If so, how does that work?
Yes, and hopefully I was thinking about that. I may do it before the class because I'm not sure I'll be able to. There's too many of you, But yeah, how that works is I'll look at Top Hat and see what you did. It's not terribly sophisticated. Basically, if you did things in Top Hat, then you'll have points, and if you didn't do anything, then you'll have less. Unless you've emailed me your sad tale of woe and it seems reasonable and not far-fetched, and then I'll adjust accordingly. No need to get COVID this week just because there's a quiz and test, by the way. Like, you don't feel the need. Like, this is not good. It's going to be okay. You can do it. This quiz is not going to be the worst. I'm pretty sure. I can tell you this. There will be a truth table on the quiz, like that much I know. Right? Certainly there will be truth table or tables. So, any other questions? All right.
It's Thursday, right?
It is this, yes, Thursday, as in, what's today's date? So 15th. The 15th is when quiz 1 is, right? And I believe that's what's on the course planner, right? So you can always look back at that course planner. Yep.
One more thing, will there be any fuzzy sets that are in the book but that you haven't talked about in the lectures on the quiz?
You want a question on fuzzy sets?
No.
Oh, no. Oh, okay. No, I would not. That would just be mean. No, I mean, I try to be mean, but not like that. No, I wouldn't foresee me asking a question about fuzzy sets, although they're interesting. And if it's in the book, but I haven't talked about it in class, odds of it being on the quiz are low. If I've talked about it in class and it wasn't in the book, it's still possible, right? Like if there's some things I talked about math history in the first lecture that I might ask you a question about that stuff, some of that trivia. For what it's worth, I think I had flipped the picture of Descartes and Fermat, you might notice, but one of my students was watching this from a distance and told me I had messed up the pictures of two of the mathematicians there, so I was like, oh no. No one called me on it. So, other questions? All right, so let's talk about section 3.3 and 3.4. I'll try to just give you a quick overview of the ideas, and then I'll try to leave time for homework, okay? So we can talk about the homework. So I'll be a little bit light on examples here. So first of all, the conditional, the biconditional, and related statements, that's the topics for today, basically. And we talked about this a little bit before, but the conditional, right, is this P arrow Q. Now, I read that P implies Q. In mathematics, we almost always talk about implication. And so this is, but this logical statement here is the conditional, all right? And in terms of language here, P is called the antecedent and Q is called the consequent. P and Q are assumed to be statements here, right? In other words, what's a statement? A statement is a declarative sentence that has a definite true or false value, right? And so can you guys help me fill out this truth table here? What goes over here? True implies true is true. True implies false is false. False implies true is true. And false implies false is true. The only way you can get a conditional wrong or false is to do true implies false. So conditional is usually true. The only way to break the conditional is when you have true implies false. Now, I know some of you probably want to think false implies true is false, but that's not the case. That's not how this works. So let's see here. So that's the conditional. There are we could come up with an example here, I suppose. What do you guys want to make P for our example? What statement do you want P to be? This is very dangerous. I'm opening the floor. I reserve the right to reject your suggestion. Hamster. That's not a statement. I take hamster is dead. Hamster. Okay. Oh, fine. I hear your cry. Sleeping. There. Is that better? Hamster is sleeping. And Q. Let's see here. How about the hawk will eat hamster. Hawk's got to eat. What's your problem? All right, so here's how this works. If we say P implies Q, what sentence does that give us that says if the hamster is sleeping, right, then the hawk will eat hamster. All right. So that would be the sentence. Let me see. Let me try to come up with another example here. Actually, let me not do that. So how about this? Example 2. Suppose we look at if 2 is an integer, right? Then 2 is a rational number. That's one we could look at, and then we could do this if. So let's just evaluate this sentence. Is this implication true? All right. So why is this true? So this is P, right? And this over here is Q, right? Are they both? Is 2 an integer? Remember what integers are? They're like 0, plus or minus 1, plus or minus 2. So 2 is an integer. It's an integer. And rational numbers are just fractions. Whole numbers are included in rational numbers. So both P and Q are true, right? We would say P equals true, Q equals true. So this sentence is true. You know, in terms of the propositional logic here. If 2 is an integer, then 2 is a rational number. Let's see here. How about this one? If, I'll try to stick with my color code here. If, this example in the book is good, I think. If 3 is a negative number, all right? If 3 is a negative number, then Superman is in Marvel Universe. Okay, that's not in the book, but I changed it. So, is this sentence true? Is it false? So, the question then is, see, the only way for an implication to be false, right? The only way for a conditional to be false is for us to fit into this true implies false. That's what makes the sentence false, right? So in this case, is 3 a negative number? See, that's my antecedent, right? The consequence is that Superman's in the MCU, right? So in this case, the antecedent is false, and the consequent is also false, right? So the sentence is true. It's also nonsense, but logically speaking, the sentence is true, all right? So this means P, Q is true. P implies Q is altogether true, all right? Let's see if we can come up with one more example here. How about if 3 is a positive number, then I just need you guys to give me something false. Give me a false statement. How about everyone will fail the quiz? Everyone will fail quiz 1. All right, so that is false. Someone in here will pass. Come on. All right. I'm just kidding. Most of you should pass. So the antecedent here is 3 is a positive number. That is true. The consequent, Q, is this. Everyone will fail quiz 1. And that is false. True implies false, makes the conditional. So this sentence is altogether false because we fit into true, false, true implies false is false for the conditional. All right. So,
I have a question.
Yep, go for it.
Truth table. The first table on the left, so like P and Q, where are you getting those letters from?
Where?
I noticed on some problems that those letters will already be there under P and Q, like true, 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 false, false, true, false, false. But on some questions, those letters aren't there. So I was wondering how to get those letters.
Oh, you just have to make sure you list all possibilities. And so that's just a custom to list them in that order.
Oh, okay.
It's not especially, yep.
How is false implied true?
False implies true, true. I mean, by definition is the answer. Now, I mean, I can read you what the textbook says. So, like, the textbook gives this example of word processor and, word processor and, what's their silly example here? If you can use a word processor, you can create a web page, right? So their sentence for false implies true is what? You cannot use a word processor, but you can create a web page. All right. So what they're saying is, okay, just because you can't use a word processor doesn't mean that you can create a web page, but saying on the flip side of things, if you can use a word processor, then that implies you can, use a web page. So like they're not, the conditional says, the conditional only guarantees that if the antecedent is true, then the consequent will not be false. Like that's all the conditional says. Let me see if I can come up with another example. So let's think about, like usually people give this example. Let P be, it's raining, right? And Q equal ground is wet, right? So think about this. If it is not raining, right? Right? Then does that imply that the ground is dry? So the ground may be wet, right? I mean, I'm kind of outside of the symbolic thing here, but my point is the sentence P implies Q, if it is raining, then the ground is wet, but just because the ground is wet doesn't necessarily mean it was raining, right? You could have just put a hose on the ground or something. So like, that's the language that the conditional allows us, right? And to be used in the true sense. So, let's see here. Does that answer your question? Okay. But I mean, from a more basic perspective, it's just by definition, this is what we agree on this logical operation to mean. Okay, moving on here. There are other things we could look at a truth table here. Let's look at this one here. So, and getting back to the question about the truth table, and I mean to number these pages. So guys, as a general point of order here, as I write these pages out, I'll try to keep track of them and scan them after class, so you can just look at the PDF of these later if you want. All right? So I'm going to go through this truth table in the book. So example, let's work it out here. So we want to work out the truth table for, this is on page 128. So it's the truth table for P and parentheses Q or not P. All right. Close square bracket implies not P. This is quite a quite a truth table, isn't it? So what I'm going to do is I'm going to work through this thing, not quite in the style of the book. I'm going to use the other style because I think it's easier to follow. So we start with P and Q. All right. I'm going to make those. All right. And let me make it a little bit bigger here so we have lots of space. There are 4 cases. All right. So I can either do what? True, 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 false, false, true, or false, false. That just seems to be the order the book's always putting it in. It's really just a choice, right? All right. So then I want to calculate this Q or not P, right? So the next column I'm going to make to guide my thinking here will be not P. All right. So what's not P? Let me do a different color for not P. So we just do true becomes false, right? True becomes false. False becomes true. False becomes true. So there's not P, right? Next up, I will do the Q or not P. All right? Now, what do I have to look at there? What's the rule when we're doing, this is what, conjunction or disjunction? This is disjunction, right? So we need to look at column, maybe I should put a divider over here just so I can number the columns, right? All right, so let me number these columns. Columns 1, 2, 3, 4, right? Okay, so you guys tell me, which columns do I need to look at in order to decide the truth value in column 4? What do I have to look at? I have to, look at 2 and 3. And what's the rule? How do we do disjunction? If either one is true, right? Or if both is true, it's true. The only way to get false here is what? They both have to be false, right? This is how we define logical OR. So the only one that's false is going to be the second row, I believe. Everything else is true here. So what I got is true, false, true, true. If you don't follow that, you need to go back to the last lecture and you need to look at the truth table for the or, right? I'm always, if you'll allow me just a momentary digression here, I'm going back to this more basic thing, right? Let me use different letters, like, you know, A, B, A or B, right? So the basic truth table for this, true, 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 false, false, true, false, false, remember, is A or B is true in every case except for the last one, right? That was the truth table for disjunction. And so I'm using this when I fill out that green column, right? That's why I put the false here, because that's the only way to get false for disjunction, is when you have both inputs are false. Okay. Now what? What's the truth table for conjunction? So true, 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 false, false, true, false, false. What's the rule for conjunction? Remember, true, true is true. Everything else is false, right? All right, so we're supposed to figure out next up, which is what? P and, use a different color here. P and Q or not P. So what do we need? How do we figure out that column, column 5? So which columns do we need to look at? We need to look at column 4 and what? Column 1, right? So if column 4 and column 1 are both true, it's true. So we get what? True, false, false, true is false for and, false and true is false. So we get like that, right? All right, and then what's next? Everything together. So the last operation we're looking at is the conditional, which I'll write again down here. A, B. Maybe it helps to have different letters, right? A implies B. So we could have true, 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 false, false, true, false, false. Them's our choices. Again, the only way to have the conditional be false is true implies false. Everything else is true. All right? So we're looking at P and parentheses Q or not P implies not P. Ugh, that's a mouthful. So what do we have to look at then to figure out the truth value of that? To figure out 6, what do we need to do? Which columns do we have? We have to look, we have to judge this one, right? So is 5 my antecedent, or is it my consequent? 5 is the antecedent, right? And not P, which is 3, is the consequent, right? Think about this. So we have to think of this playing the role of this A right here, and we have to think about not P playing the role of the consequent, which would be kind of like B right here, right? So let's think of it this way. The only way that we can get false over here is if we have false implies true, right? So here's a false. Do we have false implies true? No, false implies false. That's true. False implies true. Uh-oh. Look at that. False implies true. False implies true. So the last 2 rows are this case right here. So thinking through it, we have false for here and here. Let me write it down. And So up here we had true implies false. That's fine. Excuse me, wait a minute. Do I have it backwards? Oh no. Oh no. Ah! What can we do? It's okay, I came prepared. Come on. Marker, do your thing. There we go. There, it never happened. We'll just hit rewind on the video, edit this part out. I'm just kidding, I'm too lazy to do that. Okay, let's try that again. So you guys got me on the straight and narrow here. So we have true implies false. That is false, right? False implies false is true. False implies true is fine. False implies true is true again. Yeah. So is the answer. All right, let me check my answer. Whew. Yes, this is what they have on page 129, FTTTT. Of course, they have used the different format. So you can contrast what I did here on page 3 to the way the book does it if you want. I'll be encouraging you to do it my way, not the book's way, on the quiz. So just so you know. Any questions about this? All right. Let's look at an equivalent form of conditional. All right, so what we're going to do, pretty simple. We're going to put P here, we're going to put Q here, and we're going to study not P and not P or Q. All right. So I'm going to make my truth table. And then to compare, we'll put the conditional over here. See how these stack up against each other. All right, so let's fill this thing out. So what I'm going to show you here in this truth table is that the conditional P implies Q is equivalent to not P or Q. All right? So here it goes. True, true. True, false, false, true. False, false. All right. So how we fill out the not P column. How's that go? False, false, true, true. Very good. And how about the not P or Q column? How do we do that? I mean, we have to, I don't want to write it out again, but let me go back to my other page. Right? You guys remember. All right, I guess I don't want to fold this thing. It's going to mess up my scanning. Haha. Sort of works. All right, so remember disjunction. We look at this, right? True, true is true. True or false is true. True, false or true is true. False or false is false. All right? Listen, guys, you need to memorize the disjunction, the conjunction, and the conditional for best results on the quiz and test. Like, yes, you can keep looking at them, but if you just take the time to memorize them, things will go much easier for you. But I think if you just do problems, you'll probably have them memorized whether you plan to or not. Let's see here. So not P or Q, what do we got? We need to look at these two, right? So what do we got? We got true, false, true, and true, right? But how does the conditional work? Remember? It's what? True. True implies true is true. True implies false. False. False implies true. True. False implies false. False. right? So then what? Look at these two. Oh, did I? Thank you. I said true, but I wrote false, or did I just say false and write false? My bad. Well, thank you. I do appreciate the corrections. Let me fix that here. So if we look at these two columns, right, what do we have? The same truth values, right? So these match. So what this shows us is that P implies Q, right? This is equivalent to not P or Q, right? So this is the so-called equivalent disjunctive form. There you go. Here's the thing logicians call it, the equivalent disjunctive form. Doesn't that sound fancy? Equivalent disjunctive form of the implication. Yep.
Will we ever have to fill out the top, or will that always be filled out? Do we just have to do the true and false part?
Yes.
That'll always be filled out?
I mean, sometimes you might have to fill it out. It depends on the problem. Sometimes it would be filled out for you. It really depends on the problem. I think I think your homework has kind of had them filled out, and then you just fill in trues and falses, right? But so really you're asking the question, it could be restated as, do you want to grade a question where the students have the freedom to put different logical things in each top column header? Or do you want to grade something where you've already put the top column headers in? It's going to be way, way easier to grade if I put the top columns in, because otherwise, like logically speaking, you could sort these things all. I mean, there's not a unique way to do it. Yeah. But at the same time, I don't really want to say no categorically. I think if I give you that freedom, it's got to be a relatively simple truth table. Otherwise, I will just go insane grading. It's true. So you can kind of judge something. If you just think about, ask yourself the question, how can he grade a question testing that aspect of it on 100 people in a reasonable time frame, given that he does sleep sometimes? That will answer some of your questions, but I don't want to just say no, but oftentimes they're filled in. Yeah. So I guess I have a future in politics. That was a pretty good non-answer, right? 4. This was 4. So if we take this out for a spin, how does this work? What did we say? What was our example? Like, well, here, I'll use the book's example. He says, if I could play guitar, I would join the band, right? If I could play guitar, I'd take his guitar and raise him an accordion. If I could play accordion, there, I'll make it more interesting. If I could play accordion, I would join the band. I'd take the band and replace it with a circus. There, now it made it more interesting, right? If I could play accordion, I would join the circus. All right, so can you rewrite this? So this is an implication form, right? Can you write this in its equivalent disjunctive form? What would the sentence look like in its equivalent disjunctive form? So the antecedent here is, I can play the accordion. That's my P, right? The consequent is, I would join the circus, right? So we want our equivalent disjunctive form would be like not P or Q, right? So what would that sentence read like? I cannot play accordion, or join a circus. So, I don't know. At first glance, it doesn't always appear logically equivalent, but I don't know. I prefer mathematical examples, honestly. These silly band joining things never quite appeal to me. All right, so that's the equivalent logical form of biconditional, the so-called disjunctive. How about the negation? Let's talk about the negation. What is the negation of the... maybe I can do it right here, actually. Well, no. My bad. So we should also talk about the negation of the conditional. What's that look like? So we've got our P, our Q, our P implies Q, right? And so we do what? True, 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 false, false, true, false, false. And again, the implication is true, false, true, and true. If you negate the conditional, what is it? So negate, P implies Q, what do we get? We get false, true, false, false. All right. Now we want to compare that to, we're going to compare that to P and not Q. All right. So I guess I need to put in another column here. Let's put in the not Q. What's not Q look like? Not Q is false, true, false, true. And then we're going to put in a last column here of, see here, changing the color. The last column will be P and not Q. Okay, so you guys help me out. P and not Q, what do we need to look at there to figure out that? So P and not Q, I look at the first column and the next to last column. In order for this to be true, I need what? I need both of these to be true, right? Because it's conjunction. So the first row gives me true, false, which is false. I get true, true, which is true. False, false, which is false. False and true, which is false. So I get false, true, false, false. Right? So what does this show? So if you look at this, right, you see that this column and that column are the same, right? And so what does this show? This shows that the conditional, excuse me, what did I do? Do you believe that? I hope you don't believe it. Where's my arrow? My arrow's off where it should be. Where should it be? Right, so I got carried away here. I meant to put the arrow to here, right? It's the negation of the implication, negation of the conditional, which is equivalent to P and not Q. My bad. I'll fix it. So this is an equivalent form to the negation of the conditional, is P and not Q, all right? And this is called, oh, they've got no fancy name for it. Oh, well. I was hoping for some sort of fancy, you know, conjunctive something or other form, but nope. All right, so there's that. If you negate the conditional, it's the same as and or not Q. That was page 5. Page 6. The biconditional. What's the biconditional?
If and only.
Ah, yes. P if and only if Q. This is read P if and only if Q. All right. And the truth table for this guy looks like this. P, Q, P. So the way this works like you guys want conditional to work. A lot of us are like default thinking is to confuse the conditional and the biconditional. See, biconditional is kind of like logical equality in some sense. So if we have, let's see, true, 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 false, false, true, false, false. So biconditional is very easy. It only is true if they match. So like true, if and only if true, this is false, and that's true. So this is the biconditional truth table. Now this is equivalent to something. Let's see what it's equivalent to. So let me put down 2 more columns here. If we do P implies Q, right? And if we do Q implies P, what do we get? Let's see, P implies Q. We've talked about that a lot today. That is true, false, true, true. How about Q implies P, though? Other way around. So true implies true, true. False implies true, true. True implies false, no go. False implies false, true. So that's Q implies P. All right? So if we make a final column here, which I'm going to have to write a little bit smaller. Sorry, poor planning on my part. But if we do P implies Q, right, and Q implies P, for this final column here, what do we get? So, yeah, we get true, false, false, true. And so that is exactly, so I think to answer your question earlier, like a lot of times when you're thinking conditional, you're really thinking biconditional, and that's why, like, I think in terms of everyday language, people don't quite get the conditional idea because they're really default. Your default conditional is the biconditional, right? And but these are the same. So what we get from that is the logical equivalence of P is if and only if Q is interchangeable with P implies Q, right? And Q implies P. So this is the biconditional, and that's why we call it biconditional, because it's both conditions at once, right? A little bit more language. What is Q implies P? What is Q implies P relative to P implies Q? It's called the converse, right? So, you know, a little bit of language here. This right here, this is the converse to P implies Q. I mean, there's a lot more to say. So in 3.4, it starts with this laundry list of equivalent statements, common forms of P implies Q. It'll about drive you nuts. So there's this laundry list of equivalent forms linguistically for the conditional. So like the way P implies Q appears in sentences in English, it has a lot of different ways it can appear. Like if P then Q is kind of the standard thing. Every P is a Q is another way of doing it. If P comma Q is another way it's written. Q if P is yet another way it's written. P implies Q, that's what I like. Not P or Q, this is the equivalent disjunctive form. Yeah. Q provided that P is another way to write it. Q is a necessary condition for P is like another way. Basically that's saying that when P is true, Q has to follow. It's a necessary condition for P. And P is a sufficient condition for Q is yet another way to look at it. So if you want Q to happen, if P happens, that's enough, right? It's a sufficient condition. It might not be necessary, like the ground can be wet even though it's not raining, right? So it's raining is not a necessary condition for the ground to be wet, although it is a sufficient condition for the ground to be wet. So as you're parsing word problems in the homework, keep this table in mind. It'll help you like work the problems. Let's see here. So we've talked a little bit about the converse. There's also inverse and contrapositive. What's the contrapositive? So let me just write it up here. Converse of P implies Q is Q implies P. All right. Inverse of the conditional is not P implies not Q. And the contrapositive of the conditional is not Q implies not P. All right. So there's a nice truth table, which if you don't mind, I'm just going to use the book here. So like, see right here? So if you look at the truth table, so here we have the truth table for the conditional. It's converse, it's inverse, and it's contrapositive, right? And if you look at this, you see that the contrapositive, right, has the same truth values as the conditional, right? So the contrapositive is logically equivalent to the conditional. But on the other hand, the converse and the inverse are not logically equivalent to the conditional. However, they are logically equivalent to each other, right? So, all right, so I could go on and talk more about this, but I think I should stop and let you guys ask questions about the homework if you got them. So, shoot. Yes?
How does the logic gates and the other thing on the homework?
The switches, possibly, because I spent time talking about that in class. But since I didn't get to the logic gates, I wouldn't put those on the quiz.
But could you explain, I got the first one right, but can you the last question with the sheriff stroke and
The Sheffer stroke and the, I could try. Let me, so like here's a quick rundown on that stuff. So some of this is another notation which you can ignore if you want, but so which one were you looking at exactly? The
it's the last question.
See, annoyingly, when I printed it out, for me, it's done this. So So is it part A of the last one?
Yes.
Let me see if I can do that. That is this one?
Yeah.
All right, so let me try to work through, well, I've kind of worked through it here already, right? Let me try to explain what I'm doing there. Maybe I can zoom in. All right, so here's the way it works. The input stream here is 1100, right? So that goes to this lead, but it also goes to that one, right? 1010 goes to this one, but it also goes to that one. This is an AND gate, all right? This diagram means AND. It's like logical conjunction. The only way for the output to be a 1 is if both of the inputs are 1, all right? So like the output before that little circle dot, you could think about it as 1, 0, 0, 0. But that circle dot is an inverter. It's a negation. So that flips the 1, 0, 0 over to a 0. Excuse me. 1, 1, 1, 1. So there's that. And the same thing happens down here because it's got exactly the same inputs. So this is an AND gate followed by a negation, which is called a NAND gate. So we have the NAND gate and the NAND gate feeding into yet another NAND gate. And so what happens is, if you think about it, it's going to be false, true, true, true. In other words, 0, 1, 1, 1. But then the negation flips it over to 1, 0, 0, 0 is the output. So that's why the output stream is 1, 0, 0, 0. I'm sorry, I seem to have told you the answer to number 20, part A, everyone who's paying attention. So about half of you. Yep. Sure. I mean, yeah. I mean, if you want. Oh, you don't want? Oh, okay. Listen. Some of you have spent time reasoning through this, so I at least would I might put a bonus question. Let's say that this would just be a bonus question. It wouldn't be part of the required thing, since I have not spent a lot of class time talking about these gates. I thought it would be interesting to you guys. So I put in the homework. I may have been wrong. Yep.
For the coding test, are we allowed to bring like scrap paper to write out problems and stuff?
Yeah, you can. Well, there should be space. So the question was, can you bring scrap paper to the test? The answer is not really. So I want you to write on the test, and I will provide room on the test. Let's look at a couple homework problems while we're here. Still have a couple minutes, right? So you'll forgive me if I'm telling you the answers to some of your homework, right?
I'm just still confused.
You won't be too upset, right? All right, so here's let's talk about these together, okay? Question 17, determine whether the statements are equivalent. If Kevin wins, we will celebrate. If we celebrate, then Kevin will win. What are these examples of? If the first is P implies Q, the second is Q implies P, right? So the one is the converse of the other. Are those logically equivalent? No, right? We learned that the conditional and its converse are not logically equivalent. So no, these are not equivalent, all right? How about this one? If she attends the meeting, she will make the sale. All right, if she does not make the sale, then she did not attend the meeting. What is this an example of? The first statement we could think of as P implies Q, right? The second sentence you could think of as, let me write this down. Let me write this down here. So I'm saying these things, but let me write these things. So this is like P implies Q, right? This is interchangeable with Q implies P. Those are not logically equivalent, right? If the first one is P implies Q, right, what's the second one? Not Q implies not P, right? And what is that? I know that is the contrapositive, and that is why it's logically equivalent, because the contrapositive is logically equivalent to the conditional. All right? So that's why that's the case. How about here?